Good morning. I'm Spot On Weather meteorologist Matthew Euler, and welcome to the Teleconnections discussion for 8 October 2021. A couple interesting images here on the left. I'm showing a graphic from December of 2010. You'll notice that purple shading in the upper right-hand portion, or to the right-hand side of the graphic on the left, that purple shading indicating extremely high, anomalously high 500 millibar heights over northeastern Canada into Greenland. And then that blue shading, anytime you see the blue shading there on the graphic on the left, indicates anomalously low 500 millibar heights associated with troughs in the middle atmosphere. So just wanted to show you what a typical pattern would look like on the left there of a negative NAO, where you get this ridging into the North Atlantic side into Greenland. Generally you get colder temperatures along the U.S. East Coast. The graphic on the right shows a great example of what happens when the stratospheric polar vortex is disrupted. You'll notice the blue shading that goes all the way from the top of that graphic on the right down into the lower 48, into the Midwestern U.S., down into the East Coast, the blue shading indicating those below normal heights once again, and the orangish shading the above normal heights. So in the case on the graphic on the right, we had a huge ridge over the northeastern Pacific into western Canada with a very highly amplified trough downstream into the Midwest and the eastern U.S. So we had a direct Arctic connection in this case on the graphic on the right. All right, so let's get into today's teleconnections discussion. We're starting to move into the cooler season, so I figured we'd start doing these discussions again, similar to last year. Let's first start by taking a look at the hemispheric upper air pattern. I pulled this chart from basically yesterday afternoon on Thursday, 7 October 2021. A couple main features are influencing the weather across the United States right now in the upper air pattern. We have an anomalous ridge located from New England, stretching from New England area up into central Canada. And this ridge has been very persistent. Even in the forecast out the next 5 days, that ridge continues to remain in place. So it's very interesting to see this high latitude ridging already kind of connecting up to the Arctic area on the North America side. Additionally, we have a upper level trough position in the northeastern Pacific off the U.S. West Coast with a ridge upstream from that. In general, I'll show you the sea surface temperature anomalies, which I find real interesting right now, and I'll kind of explain why here in a bit. Additionally, we have a cutoff low that is situated over southern Missouri into Arkansas. And the upper low, things have been kind of stuck in neutral across the eastern United States as far as any weather changes. It just simply not happened, as we have warm, moist air dominating anywhere from the southeastern U.S. up through New England, with really no appreciable changes to the jet stream, with it being well back to the northwest of the mid-Atlantic. We generally have a very stagnant weather pattern right now due to these positioning of these upper level features. I'm going to start the teleconnections discussion with the review of the MJO for the upcoming forecast period. Just a reminder on how to read this MJO forecast diagram. In general, the MJO ranges from phases 1 to 8. And if you look at the overall distance from the origin, or that smaller center point, the smaller circle in the center of the diagram, that distance from the origin represents the Madden-Julian oscillation amplitude. The circle denotes amplitudes of 1 standard deviation. In addition, the phase of the MJO is indicating the approximate location of enhanced convection. And the dark green lines on these forecast charts I'm about to show you, they generally show 45 days out of the MJO phase in amplitude from the forecast ensemble mean. The green asterisk on this MJO phase diagram denotes the start of the forecast. Numbers are the day of the month, so you see these small little numbers, that's the day of the month. And then individual ensemble members are denoted by the lighter green lines. Okay, so there's a wide range. When we talk about ensemble models, we're talking about a wide range of possibilities. The black line, when you see it on the MJO phase diagram, that shows 20 days of observed MJO's values and the amplitude prior to the initialization. The black asterisk denotes the start of these observations, and the numbers, again, are the day of the month. So just wanted to reacquaint you with the MJO phase diagram. Phases 2 and 3, generally we have enhanced convection in the Indian Ocean. With phases 4 and 5, that enhanced convection is located over the maritime continent. With phases 6 and 7, the enhanced convection is located over the western Pacific. And then phases 8 and 1 generally equate to enhanced convection over the western hemisphere in Africa. So I just wanted to show you again, what this phase diagram looks like. This is a great explanation of it. So hopefully it'll help you in your understanding when I go over it in the video. In general, these are the MJO phases and where you typically see areas of enhanced convection in the equatorial western Pacific into the Indian Ocean. So you kind of see there that, for example, phase 8, we have an enhanced convection closer to the international dateline at that 180 degree west longitude point. Phases 4 and 5, we'd have enhanced convection over northern Australia. Phases 1, 2, and 3, generally in the Indian Ocean, is where the enhanced convection would set up. So, you're looking at the tropical areas, you're saying, oh, this is pretty far away from where I live in the United States. But these MJO phases and where the enhanced convection sets up and these vertical circulation changes, they really make a difference as far as setting things up for our sensible weather in the United States. So here's a look at the MJO. These are the temperature composites on the left. And I'm starting the temperature composites out for October, November, and December. In general, for this time of year, we expect by the way, the blue shading on that graphic on the left represents cooler than normal temperatures, and the orange shading and the yellowish color indicate above normal temperatures. And so this time of year, October, November, December, we'd expect to be cooler across the eastern United States, generally with a phase 5 and phase 8 specifically, as well as phase 2. And if we were basically in an MJO phase 3, we would have milder temperatures. You can see the orange shading there. So just wanted to throw that out there with these temperature composites, which are available at the Climate Prediction Center website, the NOAA Climate Prediction Center website. Additionally, these temperature composites change. So the specific MJO phase and the expected temperature departures from normal, that changes between, throughout the year. So the December, January, and February temperature composites will not look the same as the October, November, and December composites. All right, so let's get into the forecast for the MJO. We're looking at the GFS Ensemble forecast on the right, and you'll notice the green lighter color line there. That generally indicates that we're currently in a phase 5 of the MJO. Over time, you notice how that green line kind of goes back towards the center origin point of the diagram, and that smaller inner circle at the center of it. That means we're going to go from MJO phase 5 to a null phase by the 21st of October. This is the latest GFS Ensemble forecast. We look at the GFS Operational Model MJO forecast. Very similar. We're expecting that the MJO is starting out in phase 5, and it kind of drifts its way back towards that center point of origin, the smaller inner circle. So we're going to transition from a phase 5 to a null phase once again through the 21st of October. Looking at the La Nina update, NOAA, the Climate Prediction Center, is after looking at the model data, we're expecting there's a 70 to 80% probability that La Nina occurs this winter season. In general, the sea surface temperature anomalies, that graphic's on the left. Blue coloring on that graphic on the left indicates below normal water temperatures, while orange coloring indicates above normal water temperatures. So right now, there's a couple features I really want to point out on the anomaly map on the left. The first one is the blue coloring there in the equatorial eastern Pacific, west of South America, on all the way into the central Pacific along the equatorial areas. That's associated with a developing La Nina. All right. And if you look at the graphic on the right, that shows generally the temperature trace of what the water temperatures are like in that Nino 3.4 region. Okay. In general, we're looking at 0.6 degrees Celsius below normal water temperature in the Nino 3.4 region right now. You can see by the blue line on the right the general tendency or trend of the line. Since mid-September, we've seen a steadying out and then a gradual step down or cooling of the water in the Nino 3.4 region. In general, in the past week, things have kind of leveled off, steadier temperatures over the past week. Another main feature I want to point out that can really impact our weather, I talked about this on previous videos, is the Pacific Decadal Oscillation. And you'll notice in the Gulf of Alaska there's a blue shading on that graphic on the left. And that blue coloring, again, indicates below normal water temperatures. So right now in the Northeast Pacific, which for us in the United States is very important, especially when it comes to the configuration of the jet stream, the Pacific jet stream, okay? Blue shading, we got a lot of cooler than normal water in the Gulf of Alaska right now off the west coast of Canada. While south of that, we got this orange shading there. That's warmer than normal water temperatures across the central North Pacific. And so the greater that temperature contrast between the cooler water to the north and the warmer water to the south, the stronger the upper level jet stream winds will be. And generally when you get that strong contrast in this kind of pattern, you typically get a stronger Pacific jet stream. So this is something that's going to have to be watched closely, especially as far as the winter weather goes, the winter weather pattern, the jet stream configuration. Will we have a highly zonal west to east jet stream across the Pacific this upcoming winter? Right now, that is definitely what it looks like it's going to be the case. Additionally, on that graphic on the left, you'll notice warmer than normal water temperatures up off Nova Scotia, over the North Atlantic, off the northeastern coast of Canada, into Hudson Bay even. So we got to keep an eye on this. I'm watching it and monitoring it very closely. So now let's move to the Arctic Oscillation forecast. If you look at the Arctic Oscillation, generally a negative AO on the left and the positive AO on the right. So with a negative AO, you generally get colder air that's going to basically move from higher latitudes into the United States, specifically the Midwestern U.S. as well as Eastern U.S. Okay, it'll be with a negative AO, you typically get warm and drier weather up into Alaska, up into the west coast of Canada, up into the west coast of the United States. You get more of a stronger East Pacific ridge with a negative AO out in the Pacific. You also get a stronger North Central Atlantic ridge. So in general, I want you to think with a negative NAO, think cooler than normal weather across the Midwest and Eastern U.S., warmer than normal out in the Western U.S. Positive AO, we flip things around. Okay, we got more of a west to east jet stream, a highly zonal jet stream with a positive AO, and the overall polar vortex tends to remain locked up over the Arctic areas, the North Polar areas, and with a positive AO, we get lower pressure over the Arctic areas, again, stronger polar vortex, and a general west to east jet stream, which tends to usher in milder temperatures from the west to the east coast. So let's take a look at the forecast here. First, we'll start with the European deterministic model for the AO. Generally, we're starting off on the negative side, magnitude of around -2 according to this model. And eventually, you'll notice the line, the white dots there, or the white circular shape, that line right there, you'll notice how it kind of trends back up towards that zero line, kind of towards a neutral territory. Yes, there's a small dip there around the 13th of October back into negative territory, but it doesn't really last long. So in general, we're expecting negative to near neutral AO conditions or phase through the just about the 17th of October. We'll look at the European EPS AO, 50 perturbed members. In general, starting off negative today here on the 8th of October, and then it generally trends back towards neutral by the 10th and dips slightly negative again around the 13th, but then back to neutral in the long run. This model going out to 22 October. The European EPS, Arctic Oscillation, 50 perturbed members. Now this one goes out a little bit further in time, all the way out to around the 18th of November. I want you to just pay attention to the green line on this particular forecast. This shows the ensemble mean, generally where the average of all the ensemble models, those particular runs, where the actual positioning will be of the AO. So one thing I wanted to mention too with this longer range European EPS, 50 perturbed members, this model has a positive tendency in the longer range. I've just noticed it over time. But generally we're expecting nearly neutral AO conditions from 11 October to 16 November with this particular model. Looking at GFS deterministic AO forecast, again, just like the other model, starting out negative, and then eventually the AO trends more towards neutral around the 11th of October, dips slightly back negative between the 12th and the 15th, but then it goes positive towards the end after 21 October. So just in general, negative transitioning to positive phase of the AO after 21 October, according to this model. And then the NCEP Jeff's GFS Ensemble Forecasting System V12 AO forecast 30 perturbed members in this case. In general, we have a negative trend moving up towards neutral, then a dip back negative again between the 12th and the 18th of October, and then again transitioning back to neutral after 20 October. Moving on to the NAO, North Atlantic Oscillation Forecast. Just a reminder of the phases of the NAO. Positive NAO phase is on the left. Typically what we see with a positive NAO phase is a fast-moving west to east jet stream, much milder conditions across the Midwest and the East Coast. You generally get this stronger Atlantic jet stream with a positive NAO phase, where you've got a stronger Icelandic low, and then to the south of that you have a stronger Bermuda high. So you got winds that are moving pretty quick west to east across the Atlantic at the jet stream level, and this generally tends to lead to warm and wet conditions across Western Europe. The graphic on the right shows a negative NAO phase. So now you'll notice that jet stream, it tends to buckle, or it tends to have much more amplified pattern to it. The winds in the jet stream slow. The pressure differences between the Icelandic low and the Azores highs weakens, or the gradient's not as tight. And you tend to get a trough configuration of the jet stream over the eastern U.S. with cold and snowier periods in the wintertime. And you get this huge upper-level ridge that builds into Greenland with a negative NAO phase. In general, you get another trough that sets up into parts of the Mediterranean, for example, the Mediterranean Sea. Here's the forecast for the North Atlantic Oscillation, the European deterministic, showing a negative NAO, initially transitioning to neutral phase around mid-October. The European EPS, North Atlantic Oscillation, 50 perturbed members, showing negative phase right on through about mid-October, maybe slightly to the right of that, transitioning to neutral after the 16th of October. The European EPS NAO 50 perturbed member 46-day forecast going out to 18 November generally shows a negative NAO transitioning to neutral conditions between 11 October through 18 November. So a lot of the models are signaling negative initially in the NAO, transitioning to neutral. And then the GFS deterministic, slightly more negative than the other models, especially when we look at right on through mid-October. But then you see how it trends slightly positive around the 16th of October, negative around the 18th and 19th of October, then back positive again. So if you average that out to the right-hand part of the graphic, that's going to be a neutral condition generally. And the NCEP Jeff's V12 NAO 30 perturbed members out to 23 October, generally a negative NAO. Again, that's the common theme, transitioning neutral phase, 16 through 23 October. Let's look at the Pacific North American forecast, PNA. All right, just a reminder, the differences between a positive PNA versus a negative PNA. The positive PNA graphic is in the lower left. The positive PNA the negative PNA is in the lower right. So we got negative PNA, we got a positive PNA on the left and a negative PNA on the right. In general, with a positive PNA, we get increased chances of below normal temperatures across the eastern U.S. And then you get more of a western ridge and eastern trough. Coolest temperatures in the east, warmest temperatures in the west, with a positive PNA. With a negative PNA, you get increased chances of above normal temperatures across the eastern U.S., with our region being on the western fringes above normal temperatures. So basically with a negative PNA, it's the opposite effect. We get that troughing in the western U.S., cooler temperatures there, and the ridge and much warmer temperatures across the eastern U.S. Here's the forecast, the European deterministic PNA forecast, generally showing a fairly strongly negative PNA phase here. It's not getting close. It's not even getting close to the zero line here on this particular model. So negative PNA phase through 17 October. If you look at the European EPS PNA 50 perturbed members, showing again strongly negative, and it doesn't really recover to a neutral PNA until around the 20th of October. That generally the 21st and 22nd October, it's fairly neutral. You look at the European EPS PNA 50 perturbed members, generally showing a negative PNA through the 20th of October, transitioning positive from the 20th of October through the 1st of November, and then back neutral to kick off the month of November. Looking at the GFS deterministic PNA forecast, generally showing a strongly negative PNA, transitioning to neutral generally around the 17th and then becoming positive after the 21st of October. And then the NSEP JEFS V12, PNA 30 perturbed members, strongly negative, generally through the 19th of October, transitioning to slightly positive after that, neutral to slightly positive after the 18th of October. Now on to the Eastern Pacific Oscillation Forecast, or EPO, generally showing a negative phase EPO on the left and a positive phase EPO on the right, and the general pattern. So you notice with a negative EPO, we tend to get this upper level ridge in the northeastern Pacific into the Gulf of Alaska with a area of low pressure to the east of the Hawaiian Islands. So we got a high over a low pressure with a negative EPO. And what this does is that ridge builds up into Alaska. On the front side or the east side of that ridge, cold air is allowed to move south from the Arctic areas into the northern plains, the upper Midwest, and generally the jet stream kind of works its way off the mid-Atlantic coast in this case. So it's a colder pattern with a negative EPO, specifically for those in the upper Midwest and the northern plains. The graphic on the right shows a different effect in the Pacific. So now the pressure systems are reversed. So we have an area of low pressure in the Gulf of Alaska with a positive EPO, with an area of high pressure down towards the Hawaiian Islands. And in this case, you get a stronger west to east, highly zonal jet stream with a positive EPO. And generally, that west to east jet stream extends right on into the United States from the west coast to the east coast. So mild Pacific air dominates the lower 48. You generally have lower pressure to the north, and the coldest temperatures remain confined to the Arctic. Let's take a look at the European deterministic EPO forecast out through 17 October. It's looking mainly positive. Positive EPO from the 8th to the 17th of October. So when we talk about positive, we'd expect that area of low pressure to be in the Gulf of Alaska. So just keep that in mind. The European EPS, EPO 50 perturbed members forecast, also forecasting a mainly positive EPO through the 22nd of October. It does dip down closer to neutral there around the 17th, but then it moves right back up to positive territory. If we look at the ensemble mean, the green line there for the European EPS, 50 perturbed members, generally out through the 46-day forecast out to the 18th of October, you generally notice a positive trend of the EPO, eventually transitioning more neutral around the 10th to the 11th of November. And then the GFS deterministic EPO forecast, generally showing a positive trend, a lot of ups and downs in this particular model for the forecast. But in general, if you balance things out, we're looking at positive conditions overall through the 22nd of October. And then the NCEP Jeff's V12 EPO 30-per-term members forecast showing generally a positive, mainly positive EPO right on through the 22nd to the 23rd of October. All right, now I'm going to move into a quick update on the stratospheric polar vortex. Really, I believe this is a real big wild card for the upcoming winter season for the United States. You know, does this thing stay strong all winter like 2019-20 winter? Does this polar vortex weaken, get displaced, or become elongated over the course of the winter season? These are the latest models. This is the NCEP GFS model I'm using. Generally, I want you to pay attention to the coloring here. Now, these charts show the temperatures up at 10 millibar level. Okay, so way high up in the atmosphere, above 18 miles. Generally, I want you to pay attention to the Arctic area, the North Polar area. The graphic on the left is the present time, the current time. You notice the blue shading represents colder temperatures, okay? The red shading generally indicates, these are anomalies, by the way. So the red and the orange shadings, those indicate well above normal temperatures at that particular level in the atmosphere. And so the graphic on the left starts out on the 7th of October. You notice it's fairly blue shading across the Arctic area, the polar areas. The graphic on the right shows the forecast for 22 October. So you notice how that blue coloring on the left is replaced by the darker orange shading on the right over the Arctic areas. That is what's known as a stratospheric warming event, where the temperatures can warm drastically, above 18 miles above the surface in the stratosphere. And this is forecast by this particular model, which would then tend to weaken the polar vortex. This could lead to cooler temperatures in late October and early November. Looking at this model a couple days ago, it appeared that the coolest temperatures would be displaced from the Arctic higher latitude areas into Eurasia. So just because this occurs, weakening the polar vortex, does not necessarily mean the coolest air is going to flow down into the United States. It could actually move into Eurasia instead. So this is something to keep an eye on. Overall, I did take a look at another model, and it showed the polar vortex basically being stretched or elongated generally around the 21st, 22nd of October. So, we're already seeing signs of weakening the polar vortex. Now, does this mean that the whole winter is going to be influenced by a weakened polar vortex? Absolutely not. This thing could re-strengthen after this particular episode, and we could have a very mild winter. So this is something, again, a wild card factor in, I talked about it in my winter forecast video for the upcoming winter season. All right, so here's the final thoughts on today's teleconnections discussion. The MJO is currently in phase 5 and is transitioning to the null phase through the 21st of October. Phase 5 would typically indicate cooler temperatures across the eastern U.S., just throwing that out there. Null phase is generally going to indicate minimal impact. So we do expect the MJO really to not be as impactful for the temperatures across the United States. Now, the La Nina conditions continue developing across the equatorial eastern Pacific. Again, we're sitting at a 0.6 degrees Celsius below normal water temperatures in that Nino 3.4 region. La Nina generally favors milder temperatures across the eastern U.S., the mid-Atlantic in general, specifically for the upcoming winter season. Sea surface temperature anomalies, I showed that graphic. We generally have cooler than normal water across the Gulf of Alaska. Now, I want to see, what I'm really curious to see over time is what happens with that cool pool of water over the Gulf of Alaska. Does that stay in place throughout the whole the course of the upcoming winter? If it does, if that area of low pressure tends to just stay there in the Gulf of Alaska, it's generally going to most likely result in milder conditions for the eastern United States this winter. But if that cooler than normal water becomes milder or warmer over time, and then we get an upper level ridge in the Gulf of Alaska, that could totally change the temperature outlook for the upcoming winter for sure. But as of right now, we have that cool pool of water in the Gulf of Alaska. And we also have warmer than normal water over the central North Pacific Ocean, favoring a more zonal west to east Pacific jet stream pattern. Tightened pressure gradient, tightened thermal gradient, that's what's going to lead to the stronger upper level winds, the jet stream. Now, models are indicating a negative trend in the AO transitioning to neutral between 15 and 20 October. This favors neither colder or warmer temperatures. And then models are also indicating a negative trend in the NAO, transitioning neutral around the 16th of October. We expect cooler temperatures over the East Coast. That's typically favored with a high latitude block with a negative NAO. So just keep that in mind. Overall, the models are indicating a strongly negative PNA. Now, I really believe that negative PNA, this is really the reason why we're seeing such mild temperatures across the eastern United States with this upper level ridge. That negative PNA, we got a fairly deep, highly amplified trough across the western U.S. So out of all the teleconnections right now, I would say there's two things really that are really dominating the overall pattern. The first one is those cooler than normal water temperatures in the Gulf of Alaska. Okay, generally have a trough and an area of low pressure, storminess across the Gulf of Alaska. That is very influential on setting up the overall jet stream pattern in the Pacific, which of course that impacts us in the U.S. My other major factor right now, as of today, the 8th of October 2021, is the strongly negative PNA. And I mean, this isn't even close when I showed you the graphics for the PNA. I mean, this thing is negative, and it's pretty significantly negative. Outside of this, this model eventually has it recover to more positive territory, but in general, this thing is So I really believe that strongly negative PNA is really playing with the weather regime right now across the United States. Additionally, models are indicating a positive trend in the EPO, and that would also indicate milder temperatures across the eastern U.S. So remember, a positive EPO means that we have low pressure in the Gulf of Alaska and high pressure down towards Hawaii Islands. So just keep that in mind. Models are indicating an elongated stratospheric polar vortex by the 22nd of October. Now, if this thing were to elongate and get stretched, there's a possibility, we could see cooler temperatures across the eastern U.S. in late October and early November. Possibly, right? Again, no two stratospheric warming events, weakening polar vortex events are ever alike as far as the after effects on where the coolest temperatures go. So this is something to keep an eye on. This is something in the back of my mind as far as the overall pattern across the United States. So my overall assessment is that La Nina is definitely developing. It's developing into a weak state across the equatorial eastern Pacific. This favors milder temperatures overall across the U.S. The Mad-Julian oscillation, it will be a minimal impact over the next 2 weeks. It's heading towards the null phase, so I'm really not expecting much of an impact from MJO. Sea surface temperature anomalies definitely favor a milder regime across the U.S. as a whole. Outside of that troughing off the U.S. West Coast, once that trough lifts out, I expect it to be fairly mild with a more zonal west to east Pacific jet stream. The AO and NAO trend is going towards a neutral state, and this is going to favor neither warmer nor colder temperatures for the eastern U.S. The PNA is a major player. It's definitely a major player right now, again, as I mentioned, in a strongly negative state with a deep upper trough and coolest temperatures over the western U.S., and it's been very cool as well up in Alaska. And then we have a downstream ridge and mildest temperatures over the eastern U.S. with this strongly negative PNA. The EPO is forecast to be positive, favoring milder temperatures in the eastern U.S. as well, while the stratospheric polar vortex weakens by the end of October, towards the end of October there. So overall, I'm expecting mild temperatures and relatively benign weather over the eastern U.S. through the 17th of October, with a general cool down expected for late October. Now, that's based on putting all these teleconnections together and with this overall assessment. Now, sure, it looks like we may have some kind of low pressure system that may come up off the mid-Atlantic here within the next 48 hours. But after that system passes through or by the area with rain, it's looking fairly benign in the weather pattern and relatively mild. Even next week, the week of 11 to 15 October, is looking very mild. So again, I'm happy to be back doing the Teleconnections discussions. My overall plan would be to do these on a weekly basis, just kind of break down what's going on with all the teleconnections and the possible implications for the weather pattern, whether we'll see cooler or warmer than normal temps, wetter or drier conditions, looking at the some of the latest climate models or dynamic models showing a milder La Nina type weather pattern for the U.S. this upcoming winter. But I tell you what, it's going to really depend, again, as I stressed before, on the strength of the La Nina. Okay, the weather charts and the models were showing the same thing last fall for last winter with La Nina. They were showing above normal temperatures across the south and the mid-Atlantic, and the typical colder temperatures back towards the northern areas of the U.S. But again, it depends on the strength of the La Nina. All right, that wraps things up today. I hope everybody enjoyed this video. Happy Friday to everybody out there watching, wherever you are. I'm hoping you're enjoying these videos. Take care, everybody. I hope everybody stays healthy and well. God bless. This is Spot On Weather. Take care, everybody.